In today's lesson, we are going to look at the underlying meaning for absolute value. So we've seen absolute values before, but we're going to now explore it a little bit more in detail and look at the geometric interpretation of absolute value. So if we think about absolute value, the absolute value of a real number x, and remember, these little bars imply that we're dealing with an absolute value if we have an expression, a real expression inside those little bars. The absolute value of a real number is either x, if x is 0 or positive, or else the opposite of x if x is negative. So this is if 0, if positive. So what is this saying? This is saying that I'm going to take the absolute value of x, and x in this case can be two things. X, case 1, could be a number or an expression that is greater than or equal to 0. So that is case 1. The second case is that if that input x is less than 0, a negative value. So that's the second case. So absolute value has to be viewed in two different cases. If the input is positive or 0, then I'm going to just keep the x. So if the input is positive or 0, then I'm going to keep the x. However, if that input x is negative, case 2, I am going to take the opposite of that value x. So let's go ahead and take a look at how we can evaluate expressions with absolute values. So we need to rewrite each expression. Now, this is saying, well, let's look at the input. The square root of 5 is approximately what? Well, it's going to be, well, it's greater than the square root of 4, which is 2, but it's less than the square root of 9, which is 3. So I need to think about that input. Is this going to be positive or negative? Well, it's going to be negative. This is going to be a negative value. So I'm going to use case 2. Because that input is a negative value. So what does that mean? That means I need to negate what is inside. So I need to negate this expression. So what does that mean? That means I'm going to distribute that minus sign, and I'm going to get negative square root of 5 minus a minus becomes plus 13. So that is all I have to do. Without a calculator, I could go no further. Now, let's look at the next example. In the next example, well, I only have an absolute value in the denominator. So I'm going to leave the numerator alone, but now I'm going to look at the denominator. Notice what's on the inside of the absolute value. It is a negative value. So what am I going to do to that negative value? I am going to negate it because the inside, the input to that absolute value is case 2. It's negative. So then if I were to simplify this further, I would get negative 7 over positive 7, which reduces to negative 1. Now, let's look at the next one. In the next example, I have big absolute values, but within that big absolute value, I have two absolute value expressions. So the first one is this one. The second one is this one. So I'm going to simplify each of those, and then I'm going to take the absolute value of the result. So if I look at the absolute value of negative 5, well, the input is negative, so that means I'm going to take the opposite of it. Okay? And then if I look at negative 13, again, the input to that absolute value is negative, so I'm going to have to take the opposite of that as well. Now, this is a lot of negatives and subtraction, so let's be very careful. So that means I have, again, still inside these big absolute values, this minus a minus 5 becomes 5. and then I have minus a minus 13, which becomes a positive 13. So now I have to do this again. I have to evaluate what's inside the absolute value, 5 minus 13, and I'm going to now take the absolute value of negative 8. That input is negative, so I have to take the opposite of it, which means my final answer is just 8. So that's how we want to look at absolute value. Two cases. Now, let's think about the geometric interpretation of absolute value. If I have the absolute value of x minus a, the way you should really think about this is I'm looking at the distance between, the distance between x and a on the real number line. So distance, difference. So if I have x minus 0, well, that's just the absolute value of x. So what does that mean? That means the distance between x and 0 on the number line. So again, we translate the absolute value as the difference, the distance between x and some number a on the number line. Again, absolute value is distance, and that is why our result is always positive. That negative sign, that minus sign, means between. So let's look at a few examples. Here you're being asked to find the distance between two numbers using absolute value. So we want to rewrite this. So if our two numbers are negative 6 and 8, I'm looking at the distance between the two, the difference, and absolute value. So this is how we would look at the distance between x and some number a on the number line. Okay, so if let's look at it on the number line. Let's look at negative 6 and 8. If I look at this distance, what is that distance? Well, we have to get negative 6 to 0, so that distance is 6, and then 0 to 8, that's another distance of 8. So that's a total distance of 14. Well, let's see how we can get that algebraically. Well, I would simplify what's inside the absolute value. Negative 6 minus 8 is negative 14. Since the input is negative, I need to take the opposite. So that is going to give me that distance of 14. Okay, let's look at the next one. The distance between negative 5 and 2. The distance between. So if I'm looking at that, again, if I want to look at it on the number line, the distance between these two numbers is what? Well, negative 5 to 0 is 5. And then 0 to 2 is a negative 2, so this whole distance is 7. Algebraically, how are we doing that? Well, we're simplifying what's inside the absolute value, that's negative 7. Since my input is a negative value, it's negative 7, I'm going to take the opposite of it, which would give me positive 7 as being the distance between those two numbers. Now, let's make it a little bit more interesting. Let's introduce some decimals. So I have negative 5.4. The distance between that and negative 1.2. Distance, again, is the difference between those two, the absolute value. So that minus a minus becomes a plus. So I really have negative 5.4 plus 1.2 in the absolute value. If I were to add those two together, what am I going to get? I'm going to get the absolute value of negative 4.2, and you should be able to do that subtraction. That's simple subtraction. Since the input is negative, I have to take the opposite of it, so the distance between those two numbers is 4.2. So that's the geometric interpretation of absolute value, being the distance between two values.